October 15th, 1944, dawn broke cold and grey over the muddy fields of eastern France, 3 kilometers north of the village of Bruyères. Private First Class Marcus Washington, barely 18 years old, gripped the steering wheel of his 2.5-ton truck and watched the mist rise from the valley below. The German defensive position ahead looked impregnable. A concrete observation tower rising 25 meters above the tree line, its steel-reinforced walls thick enough to withstand direct artillery hits. Every American soldier in the 272nd Infantry Regiment knew that tower would be their doom if they attempted to advance across the open ground. What none of them realized was that the solution to their seemingly impossible problem sat idling behind them in the motor pool, attached to the back of an 18-year-old truck driver's vehicle, a standard military winch that nobody had thought to use for anything but pulling stuck vehicles out of mud. Before we dive into this story, make sure to subscribe to the channel and tell me in the comments where you're watching from. It really helps support the channel. On this crisp autumn morning, Marcus Washington was about to prove that sometimes the most powerful weapons in conflict are the ones nobody thinks to use as weapons at all, and that courage combined with mechanical ingenuity could accomplish what months of careful planning and overwhelming firepower could not. Marcus had been driving supply trucks for the United States Army for exactly 8 months, 2 weeks, and 3 days. He knew this precisely because he had been marking each day on a calendar hidden inside his footlocker, counting the days until he could return home to Detroit, Michigan, where his mother still worked the night shift at the Willow Run bomber plant. She had written him just 2 weeks earlier, telling him that she had personally riveted the wing panels on bomber number 4218, and that she whispered a prayer for his safety into every aluminum joint she sealed. The truck Marcus drove was a General Motors Corporation CCKW 2.5-ton cargo vehicle, one of over 560,000 such vehicles produced during the conflict. His particular truck, serial number G70428891, had rolled off the assembly line in Pontiac, Michigan, on March 23, 1944, just 7 months before this moment. The vehicle weighed 4,900 pounds empty, could carry 5,000 pounds of cargo, and was equipped with a front-mounted winch system capable of generating 12,000 pounds of pulling force through a system of steel cables and mechanical advantage pulleys. But on this particular morning, none of those specifications mattered to Marcus Washington. What mattered was that Lieutenant Colonel James Morrison had just informed the assembled drivers that the 272nd Infantry Regiment was pinned down 2 kilometers ahead, unable to advance because of the German observation tower that commanded a perfect view of the only approach route through the valley. Morrison was a career military officer from Kansas who had graduated from the United States Military Academy at West Point in 1938. He stood before the assembled truck drivers in his mud-stained field uniform, his breath visible in the cold morning air, and explained the tactical situation with the dry precision of a man who had delivered similar briefings dozens of times before. "Gentlemen," Morrison said, his voice carrying clearly across the motor pool area where 23 drivers stood at attention, "the infantry boys are stuck. That German tower up there has clear sight lines for 3 kilometers in every direction. Our artillery has been pounding it for 6 hours straight, and it might as well be shooting spitballs at a brick wall." Marcus glanced toward the tower, barely visible through the morning mist but unmistakably solid and threatening. He had seen plenty of German defensive positions during his months in France, but nothing quite like this. The tower appeared to be constructed of reinforced concrete, at least 1 meter thick, with narrow horizontal slits for observation and defensive fire. German engineering at its most efficient and intimidating. Sergeant Robert Chen, a Chinese-American driver from San Francisco who had become Marcus's closest friend in the motor pool, raised his hand. "Sir, what's the plan? Are we evacuating wounded?" Morrison shook his head grimly. "No evacuation route. The Germans have that valley locked down tight. Our boys are dug in about 800 meters from the base of that tower, but they can't move forward, and they can't move back without taking heavy casualties." Marcus felt his stomach tighten. He had made dozens of supply runs to forward positions, but never to troops who were completely trapped. Usually there was always some route of retreat, some way to get wounded soldiers back to medical stations. The idea of American soldiers trapped with nowhere to go violated everything he understood about how military operations were supposed to work. Private Second Class Tommy Rodriguez, a mechanic from El Paso, Texas, spoke up from the back of the group. "Sir, what about air support? Can't the flyboys take out that tower?" "Weather's too thick for close air support," Morrison replied. "And even if it wasn't, that tower is built like a fortress. Intelligence estimates it would take a direct hit from a 1,000-pound bomb to do any significant damage, and our pilots can't guarantee that kind of precision in these conditions." Marcus raised his hand tentatively. He was the youngest driver in the unit, and he rarely spoke during briefings, but something about the tactical problem nagged at him. "Sir, what exactly is holding that tower up? I mean, structurally speaking." Morrison looked at Marcus with surprise. "What do you mean, Washington?" "Well, sir," Marcus said, his voice gaining confidence, "my father worked construction in Detroit before the conflict, and he always said that every building, no matter how strong, has weak points. Usually it's the foundation or the support structure. What's supporting that tower?" Morrison consulted a map he had pulled from his field jacket. "According to reconnaissance reports, it's built on a concrete foundation, but the tower itself appears to be supported by steel framework underneath the concrete shell. The Germans built it fast, probably in the last 2 months, so they used prefabricated steel sections and poured concrete around them." Marcus nodded slowly, an idea beginning to form in his mind. His father, Samuel Washington, had worked on the construction of the Ford River Rouge complex before the conflict, and had often explained to his son how even the most massive industrial structures could be brought down if you knew exactly where to apply force. It was a matter of physics and leverage, not just brute strength. "Sir," Marcus said, "has anyone considered that maybe we don't need to destroy the tower itself? Maybe we just need to make it fall down?" The assembled drivers turned to look at Marcus, some with curiosity, others with skepticism. Morrison frowned. "Explain what you're thinking, Washington." Marcus took a deep breath. "Well, sir, if that tower was built quickly using prefabricated steel, then the foundation is probably its strongest point, but the connection between the foundation and the steel framework might be the weakest point. If you could apply enough lateral force to the base of the tower, pulling force rather than explosive force, you might be able to topple the whole structure." Morrison stared at Marcus for a long moment. "And how exactly would you apply that kind of force?" Marcus gestured toward his truck. "Every one of these vehicles has a 12,000-pound winch system, sir. If you could get the winch cable attached to the base of that tower and find the right anchor point, you might be able to pull it down." Sergeant Chen whistled low under his breath. "That's assuming you could get close enough to attach the cable without getting picked off by whoever's in that tower. And assuming the cable is long enough," added Rodriguez. "Standard winch cable on these trucks is what, 150 feet? 162 feet, Marcus corrected automatically. "But you can extend that with additional cable sections. I've got at least 300 feet of cable in my truck right now, plus the tow chains." Morrison studied Marcus carefully. "Washington, where exactly did you learn about structural engineering?" "My father taught me, sir. Before the conflict, I worked summers with his construction crew. I've seen buildings come down when you pull them from the right angle. It's all about finding the stress points." Morrison was quiet for several minutes, studying his map and occasionally glancing toward the German tower. The other drivers waited, stamping their feet in the cold morning air and watching their breath cloud in front of their faces. Marcus could hear the distant sound of artillery fire from the direction of the trapped infantry, a constant low rumble that seemed to be growing more frequent. Finally, Morrison looked up. "Washington, what you're suggesting would require someone to drive a truck to within maybe 200 meters of that tower, under direct observation from German positions, attach a winch cable to a concrete and steel structure, and then somehow generate enough force to topple a tower that's probably anchored with several tons of concrete." "Yes, sir," Marcus said simply. "That person would almost certainly be shot before they could complete the operation." "Probably, sir." Morrison shook his head slowly. "It's completely insane." "Yes, sir." Morrison folded his map and tucked it back into his jacket. "Which is exactly why it might work. Nobody would expect someone to try something that crazy." Marcus felt his heart rate accelerate. He had expected Morrison to dismiss his idea immediately, not to consider it seriously. The prospect of actually attempting what he had suggested suddenly seemed terrifyingly real. "Washington," Morrison continued, "you understand that this would be entirely voluntary? I can't order any man to attempt a mission with such low survival odds." "I understand, sir. And you'd need to figure out the technical details on your own. I don't have any engineers here who can tell you exactly how to attach a winch cable to a concrete tower or where to position your truck for maximum pulling force." Marcus nodded. "I think I can work that out, sir." Morrison looked around at the assembled drivers. Anyone else want to volunteer for this completely insane mission? Sergeant Chen raised his hand immediately. "I'll drive backup, sir. If Washington's truck breaks down or takes fire, he'll need another vehicle to complete the operation." Rodriguez raised his hand next. "I'll run mechanical support, sir. If we're going to try this, we'll need every truck in perfect working order." Within 5 minutes, every driver in the motor pool had volunteered for what Morrison was already calling the most dangerous supply mission in the history of the United States Army. Marcus felt simultaneously grateful for the support and terrified by the growing scope of what had started as a simple observation about structural engineering. Morrison gathered the volunteers around Marcus's truck to examine the winch system in detail. The mechanism was mounted to the front bumper of the vehicle and consisted of a steel drum powered by the truck's engine through a power takeoff system. The drum could wind up 162 feet of 3/4-inch steel cable, and the entire system was designed to pull a maximum load of 12,000 pounds at a rate of approximately 20 feet per minute. "The real question," Morrison said, studying the winch mechanism, "is whether 12,000 pounds of pulling force is enough to topple a structure that size." Marcus had been thinking about this problem during the entire briefing. "Sir, it's not just about the total force, it's about the leverage. If we can attach the cable high enough on the tower and position the truck at the right distance, we can create a mechanical advantage that multiplies the effective force." Rodriguez knelt down to examine the winch cable connection point. "This cable is rated for 12,000 pounds, but the weakest point is always going to be the connection. How exactly are you planning to attach this to a concrete tower?" Marcus had been wondering about this same problem. Standard winch operations involved attaching the cable to vehicles or other objects that were designed to be pulled. A concrete observation tower was not designed to have cables attached to it, and he doubted that the Germans had helpfully installed anchor points for American winch operations. "I think we'll have to improvise something," Marcus said. "Maybe wrap the cable around the base of the tower or find some structural element we can hook onto." Chen shook his head. "Wrapping cable around a concrete base isn't going to work. Concrete has sharp edges that will cut through steel cable under that kind of tension." Morrison consulted his watch. "Gentlemen, we need to make a decision. The infantry boys have been pinned down for 6 hours, and they're running low on ammunition and medical supplies. If we're going to try this, it has to be soon." Marcus looked at his truck, then at the distant German tower, then at the faces of his fellow drivers. Every logical part of his mind told him that what he was proposing was impossible and suicidal. But there was another part of his mind, the part that remembered his father explaining how the largest buildings in Detroit could be brought down by removing exactly the right structural elements, that insisted the plan could work. "Sir," Marcus said, "I'd like to try it." Morrison nodded slowly. "Then let's figure out how to keep you alive long enough to give it a shot." The next 2 hours were spent in intensive technical preparation. Rodriguez and Chen went through Marcus's truck inch by inch, checking tire pressure, oil levels, fuel quantity, and the mechanical condition of the winch system. They discovered that the winch had been recently serviced and was in perfect working order, with newly lubricated gears and freshly inspected cable. Meanwhile, Morrison studied reconnaissance photographs of the German tower and the surrounding terrain. The tower was positioned on a small hill that provided excellent visibility in all directions, but also made it a prominent target. The approach route would require Marcus to drive across approximately 1 kilometer of open ground before reaching the base of the hill, then another 400 meters up a dirt road to reach the tower itself. "The good news," Morrison told Marcus, is that the terrain provides some natural cover for the first part of the approach. There's a drainage ditch that runs parallel to the main road for about 600 meters. If you stay low and move fast, you might be able to get within 300 meters of the tower before they have a clear shot at you. Marcus studied the photographs, trying to memorize every detail of the terrain. What about the tower itself, sir? Can you see any structural details that might help with attaching the cable? Morrison handed him a magnifying glass and pointed to one of the clearer photographs. Look at the base. See those horizontal lines, about 2 meters up from the ground level. Marcus looked carefully and could see what appeared to be construction joints in the concrete, lines where individual sections had been poured and connected. Those look like weak points, he said. That's what I was thinking, Morrison agreed. If you could get the cable around the tower at that level and pull from the right angle, you might be able to create enough stress to crack those joints. Chen joined their discussion, carrying a canvas bag full of additional equipment. I've been thinking about the cable attachment problem, he said. What if we don't try to attach the cable to the tower itself? What if we attach it to something the Germans put there? Marcus and Morrison looked at him questioningly. Think about it, Chen continued. The Germans built that tower to observe and control the valley. They probably put antenna arrays, communication equipment, maybe even camouflage netting. All of that stuff has to be anchored to something solid. Morrison examined the photographs again with the magnifying glass. You're right, he said after a moment. Look at this. He pointed to a detail near the top of the tower. There's definitely some kind of equipment mounted up there, and it's got to be secured with steel cables or support brackets. Marcus felt a surge of excitement. If Chen was right, they wouldn't need to figure out how to attach their cable to smooth concrete. They would just need to hook onto existing anchor points that the Germans had already installed. But that creates a new problem, Marcus said. Those anchor points are at the top of the tower, 25 meters up. How do I get a winch cable up there? Rodriguez, who had been listening to their conversation while checking the truck's fuel system, looked up with a grin. Simple, he said. You don't pull the tower down, you pull the top off. The idea was elegant in its simplicity. Instead of trying to topple the entire tower, they would use the winch to pull down the upper section, where the Germans had mounted their observation equipment. This would serve the same tactical purpose, eliminating the German observation post, while requiring much less force and offering more realistic cable attachment points. Morrison was nodding slowly. The upper section is probably not as heavily reinforced as the base. If it was built quickly, they might have used lighter construction materials for the top floors. Marcus was already visualizing the mechanics of the operation. If I can get the cable attached to equipment mounts or antenna supports at the top of the tower, the pulling force would be concentrated on the connection points between the upper and lower sections. That's much more feasible than trying to topple the whole structure. Chen was studying the photographs with renewed interest. And if the upper section comes down, it's going to take out any Germans who are up there, plus all their observation equipment. Mission accomplished. Morrison checked his watch again. All right, gentlemen. Let's assume this plan can work. Now we need to figure out how to get Washington close enough to the tower to attach the cable without getting him shot. This was the aspect of the operation that Marcus had been trying not to think about too carefully. The technical challenges of attaching a winch cable to a German observation tower were complex but solvable. The challenge of staying alive while doing it seemed much less solvable. Sir, Marcus said, what kind of covering fire can the infantry provide? Morrison shook his head. Very limited. Remember, they're pinned down 800 meters from the tower. They can't move without exposing themselves to observation and fire from the tower. That's the whole problem. What about artillery support? Chen asked. Artillery won't help, Morrison replied. If we start shelling the area around the tower, we'll just alert the Germans that something special is happening. Right now, they probably think they're dealing with a standard infantry advance. If they see a lone truck driving toward their position, they might be confused enough to hesitate for a few seconds. Marcus felt his stomach tighten again. So the plan is to drive straight at a German observation post and hope they're too surprised to shoot immediately. That's about the size of it, Morrison said grimly. Rodriguez closed the truck's hood and walked over to join their discussion. "I've been thinking about this from a mechanical perspective," he said. "The biggest risk isn't getting shot while driving toward the tower. The biggest risk is getting shot while standing outside the truck, trying to attach the cable." Marcus hadn't fully considered this aspect of the operation. Operating the winch and attaching the cable would require him to be outside the protection of the truck's cab for several minutes. During that time, he would be completely exposed to fire from the tower. "How long does it actually take to attach a winch cable?" Morrison asked. Rodriguez considered the question carefully. Under normal circumstances, with a cooperative target and good weather, maybe 2 or 3 minutes. Under combat conditions, trying to attach to improvised anchor points while people are shooting at you, maybe 10 or 15 minutes, maybe longer. "That's too long," Chen said flatly. "No one can survive 10 minutes of concentrated fire from a defensive position like that tower." Marcus was beginning to understand why Morrison had called his plan completely insane. Even if everything went perfectly, even if he successfully drove to the base of the tower without being shot, even if he found suitable anchor points for the cable, even if the winch generated enough force to bring down the upper section of the tower, the operation would still require him to stand in the open for an extended period while under direct fire from German positions. "Maybe there's a way to speed up the attachment process," he said, thinking out loud. "What if I pre-position the cable hook so I can attach it quickly?" Rodriguez was shaking his head. "The problem isn't the hook attachment. The problem is positioning the cable correctly and making sure it's secure enough to handle 12,000 pounds of tension. If the cable slips or breaks under load, the operation fails." Morrison studied the photographs again, then looked at Marcus with an expression that was half admiration and half concern. "Washington, I want you to understand something. What you're volunteering for is essentially a one-way mission. Even if everything goes perfectly, even if you successfully bring down that tower, the odds of you making it back alive are very small." Marcus felt a cold sensation in his chest, but he also felt a strange sense of clarity. "Sir, what are the odds of the infantry boys making it out alive if that tower stays up?" Morrison was quiet for a moment. "Very small," he said finally. "Then we have to try, sir." Morrison nodded slowly. "All right. Let's figure out how to give you the best possible chance." The final hour of preparation focused on timing and tactical coordination. Morrison radioed the trapped infantry to explain the plan and coordinate the timing of the operation. The infantry would create a brief diversion by concentrating their fire on the tower at exactly 1100 hours. During this diversion, Marcus would begin his approach. Chen and Rodriguez would position their trucks at the maximum range of their own winch systems, ready to provide assistance if Marcus's truck was disabled or if additional pulling force was needed. Morrison would coordinate the operation by radio from an observation position that provided him with a clear view of both the tower and the approach route. Marcus spent the final minutes checking and rechecking his equipment. His truck carried the standard complement of tools, spare parts, and emergency supplies, plus the additional winch cable and tow chains that Chen had provided. He also carried a Thompson submachine gun, 200 rounds of ammunition, 4 hand grenades, a first aid kit, emergency rations, and a thermos of coffee that Rodriguez had insisted he take. "For luck," Rodriguez had said, handing him the thermos. "My grandmother always said that coffee made with good intentions has protective powers." At 10:55 hours, Marcus started his truck's engine and pulled out of the motor pool area. The engine had never sounded better. Rodriguez's maintenance work had left it running smoothly and quietly, with none of the mechanical hesitation that had plagued it during previous weeks. The winch system responded perfectly to his test operations, paying out and retrieving cable with smooth precision. Morrison's voice crackled over the radio. "Washington, you are clear to begin approach. Infantry diversion begins in 30 seconds. Marcus shifted into gear and began driving toward the German tower. The first part of the route followed a farm road that provided some concealment from observation, but he knew that within minutes he would be driving across open ground where his truck would be clearly visible to anyone in the tower. The drainage ditch Morrison had mentioned provided cover for the first 600 meters of the approach. Marcus drove as fast as he dared, keeping the truck low in the ditch while bouncing violently over the uneven terrain. His speedometer showed 25 miles per hour, which felt simultaneously too fast and too slow. Too fast for the rough conditions, but too slow to minimize his exposure time. At exactly 1100 hours, he heard the sound of concentrated rifle fire from the direction of the trapped infantry. Morrison's voice came over the radio. "Diversion is active. You are clear to proceed." Marcus drove out of the drainage ditch and onto the open ground leading to the German tower. For the first time, he had a clear view of his objective, and it looked even more formidable than the reconnaissance photographs had suggested. The tower rose 25 meters above the surrounding terrain, its concrete walls massive and intimidating. He could see equipment mounted near the top of the structure, what appeared to be radio antennas and observation devices. The distance to the tower was approximately 400 meters across open ground. Marcus pressed the accelerator and felt his truck respond, reaching 30 miles per hour as it bounded across the rough farm field. He expected to hear the sound of incoming fire at any moment, but the only sounds were his engine, the infantry diversion fire, and the rattling of equipment in the truck bed. 300 meters from the tower. Still no incoming fire. Marcus began to wonder if the Germans in the tower were concentrating their attention on the infantry diversion and hadn't noticed his approach. 200 meters from the tower, Marcus could now see details of the structure's construction. The base was indeed reinforced concrete, but the upper section appeared to be constructed differently, possibly steel framework with concrete panels, exactly as Morrison had suggested. 100 meters from the tower. Marcus suddenly heard the distinctive crack of rifle fire, and he saw dust kick up near his front wheels. The Germans had finally noticed him. 50 meters from the tower, more rifle fire, and Marcus heard at least one bullet strike the back of his truck. He was now close enough to see the muzzle flashes from the tower's observation slits. Marcus drove his truck to the base of the tower and stopped in the shadow of the concrete structure. The incoming fire stopped immediately. The Germans couldn't depress their weapons enough to hit a target directly below their position. He shut off his engine and jumped out of the truck's cab, his heart racing with adrenaline and terror. The base of the tower was even more massive up close, with concrete walls at least 1 meter thick. But Marcus could see what Chen had predicted. The upper section of the tower was connected to the base with visible steel brackets and support assemblies. More importantly, he could see the anchor points for the German equipment. Radio antennas were secured to the tower with steel cable stays, and there was what appeared to be a camouflage net support system that used heavy-duty steel rings bolted directly into the concrete. Marcus unreeled his winch cable and began the process of attaching it to the most promising anchor point, a steel ring that appeared to support multiple pieces of German equipment. The ring was positioned approximately 3 meters above ground level, which would provide good leverage for pulling operations. The attachment process took longer than he had hoped. The winch hook was designed to attach to vehicles and other equipment, not to improvised anchor points on enemy structures. Marcus had to wrap the cable through the steel ring and then hook it back onto itself, a procedure that required several minutes of careful work. While he worked, he could hear German voices from inside the tower, apparently shouting orders or calls for assistance. He could also hear Morrison's voice on his radio, providing updates on the tactical situation and coordination with the infantry. Washington, be advised that German reinforcements are moving toward your position from the east. Estimated time of arrival is 10 minutes. Marcus finished securing the winch cable and ran back to his truck. The next phase of the operation required him to position the vehicle at the optimal distance and angle for maximum pulling force. Based on his father's construction experience, the ideal angle would be approximately 45 degrees from vertical, which meant positioning his truck about 20 meters from the base of the tower. He started the engine and backed the truck into position, paying out winch cable as he moved. When the cable was taut and the truck was positioned at the correct angle, he engaged the winch system and began to apply tension. The initial response was disappointing. The cable grew taut, and Marcus could hear the winch motor straining, but the tower showed no sign of movement. He increased the tension gradually, monitoring both the winch load indicators and the target anchor points. At approximately 8,000 pounds of tension, Marcus heard a sharp metallic crack from the direction of the tower. Looking up, He could see that one of the steel support brackets had fractured under the load. At 10,000 pounds of tension, he heard a more substantial cracking sound, not metal this time, but concrete. One of the connection points between the upper and lower sections of the tower had developed a visible crack. At 12,000 pounds of tension, the maximum capacity of his winch system, the upper section of the tower began to move. It was barely perceptible at first, just a slight lean in the direction of the pulling force, but it was definitive proof that the structure was responding to the applied load. Marcus maintained maximum tension and waited. His father had explained that structural failures often developed slowly before reaching a catastrophic threshold. The key was to maintain steady pressure until the target structure reached its failure point. After 2 minutes of sustained tension, the upper section of the tower suddenly shifted more dramatically. Marcus could see daylight appear in the crack between the upper and lower sections, and he could hear the groaning of stressed steel and concrete. After 3 minutes, the upper section began to lean at a clearly visible angle. The German voices from inside the tower had stopped, possibly indicating that the occupants had evacuated or been incapacitated by the structural failure. After 4 minutes, the upper section reached its tipping point and began to fall. The collapse was sudden and dramatic. The entire upper half of the tower, including all of the German observation equipment, broke free from the base and crashed to the ground with a thunderous impact that Marcus felt through the soles of his boots. Morrison's voice came over the radio immediately. "Outstanding work, Washington. Target is neutralized. German reinforcements are still approaching your position from the east. Recommend immediate withdrawal." Marcus disengaged his winch system and began the process of retrieving his cable. The hook was still attached to the steel ring, which was now lying in the rubble of the collapsed tower section, but the cable could be recovered by winching it back to his truck. As he worked to retrieve his equipment, Marcus could hear the sound of approaching vehicles from the east, the German reinforcements Morrison had warned him about. He also heard new sounds from the direction of the trapped American infantry, the distinctive rumble of tank engines and the rattle of tracked vehicles moving across rough terrain. Morrison's voice crackled over the radio again. "Washington, be advised that friendly armor is moving to support the infantry. Your mission has opened the door for a general advance. Recommend you withdraw to the rally point immediately." Marcus finished retrieving his winch cable, jumped into his truck, and started the engine. As he drove away from the collapsed tower, he could see American Sherman tanks emerging from concealed positions and beginning their advance across the valley. The German observation post that had pinned down an entire infantry regiment for hours had been eliminated by one truck driver with a standard military winch. The withdrawal to the rally point took 15 minutes of hard driving across difficult terrain. Marcus was pursued by German armored vehicles for the first part of the route, but the approaching American armor forced the German forces to withdraw before they could engage his truck. At the rally point, Marcus was met by Morrison and the other drivers, who had been monitoring the operation by radio and were amazed by its success. Chen and Rodriguez inspected his truck for damage and found only superficial bullet holes in the rear cargo area. "Washington," Morrison said, "what you accomplished today was extraordinary. You eliminated a German strongpoint that our intelligence analysts had estimated would require a full-scale artillery bombardment and infantry assault to neutralize." Marcus was still processing what had happened. The entire operation, from leaving the motor pool to returning to the rally point, had taken less than 2 hours. The actual winch operation, the part he had been most worried about, had taken only 4 minutes. "Sir," Marcus said, "it was really just a matter of applying the right kind of force to the right structural points. My father always said that every building has weak spots if you know where to look for them." Morrison nodded. "Your father was right. But knowing where to look and having the courage to act on that knowledge are two very different things." Over the following hours, as reports came in from the advancing American forces, the full significance of the operation became clear. The elimination of the German observation tower had allowed the 272nd Infantry Regiment to break out of their defensive positions and advance 3 kilometers into German-held territory. More importantly, it had opened a corridor that allowed other American units to exploit the breakthrough and advance on a broad front. Chen approached Marcus as he was cleaning his equipment. "You realize what you've done, don't you?" he said. You've probably shortened this whole conflict by weeks, maybe months. That tower was the key to the German defensive line in this sector. Marcus was not sure he believed that his actions had been quite so significant, but he was beginning to understand that the morning's events had been more than just a successful improvised mission. Morrison had received radio messages from division headquarters requesting detailed reports on the operation and asking whether similar techniques could be applied to other German defensive positions. Rodriguez joined their conversation, carrying a cup of coffee and wearing a broad smile. "I've been thinking about what we learned today," he said. "The technical principles, I mean. If one truck with a standard winch can bring down a fortified observation tower, what could we accomplish with multiple trucks working together?" The question intrigued Marcus. His success with the German tower had been based on applying mechanical principles his father had taught him, combined with standard military equipment that every truck unit possessed. If the technique could be systematized and applied more widely, it might represent a significant new capability for American forces. Morrison called the drivers together for a debriefing session. He wanted detailed technical information about every aspect of the operation: the winch specifications, the cable attachment methods, the positioning calculations, and the structural failure sequence. This information would be forwarded to division headquarters and possibly incorporated into new tactical procedures for other units. "Gentlemen," Morrison said, "what we've discovered today is that standard logistics equipment, when used creatively, can accomplish missions that we previously thought required specialized assault capabilities. Washington's innovation may have opened up an entirely new category of tactical operations." Marcus spent the next hour describing every detail of the winch operation to Morrison, who recorded the information in an official after-action report. The report would eventually reach the desk of Lieutenant General Omar Bradley, commanding officer of the 12th Army Group, who would authorize the development of standardized procedures for using truck-mounted winches against German fortifications. But on this particular afternoon in October 1944, Marcus Washington was primarily concerned with more immediate matters, checking his equipment, writing a letter to his mother, and trying to process the reality that he had survived one of the most dangerous missions of his military service. That evening, as Marcus sat in his sleeping bag reading a week-old letter from Detroit, Chen approached him with news from the front lines. The American advance that had been made possible by the destruction of the German observation tower had continued throughout the day. The 272nd Infantry Regiment had captured 3 German defensive positions and taken 47 prisoners. More importantly, Chen said, division intelligence reports that the Germans are withdrawing from this entire sector. Apparently, they can't maintain their defensive line without that observation tower providing tactical intelligence. Marcus looked up from his letter. "Are you saying that one collapsed tower caused the Germans to abandon their whole defensive position?" "That's exactly what I'm saying," Chen replied. "The tower wasn't just an observation post. It was the nerve center for coordinating their entire defensive network in this area. When you brought it down, you blinded their whole operation." The implications of this information were staggering. Marcus had volunteered for what he thought was a desperate mission to help trapped American infantry. He was now learning that his improvised engineering solution had disrupted German defensive operations across a front of several kilometers. Rodriguez approached their position, carrying a field radio. "Washington, you need to hear this," he said. "Morrison just received a message from regimental headquarters. They want you to report to division headquarters tomorrow morning. Something about a commendation and a consultation on applying your techniques to other tactical problems." Marcus felt a mixture of pride and apprehension. Recognition from division headquarters was gratifying, but he was not sure he wanted to become known as the Army's expert on improvised demolition techniques. He had volunteered for one dangerous mission, not for a career specializing in dangerous missions. "What kind of consultation?" he asked. Rodriguez shrugged. "Morrison didn't have details, but apparently some very senior officers are interested in what you accomplished today." That night, Marcus had difficulty sleeping. The events of the morning kept replaying in his mind: the approach drive across open ground, the sound of German rifle fire, the mechanical process of attaching the winch cable, and the dramatic collapse of the tower's upper section. But what stayed with him most clearly was the moment when the structure had reached its tipping point and begun to fall. It had been a moment of pure physics, applied force overcoming structural resistance, but it had also been something more profound. It had been proof that individual initiative and mechanical knowledge could accomplish what conventional military wisdom said was impossible. The following morning, Marcus reported to division headquarters as ordered. He was met by Colonel William Harrison, the division's chief of staff, who explained that word of the Winch operation had reached the highest levels of American military command in Europe. "Washington," Harrison said, "what you accomplished yesterday has attracted attention from General Bradley's headquarters. They're interested in developing standardized procedures for using logistics equipment in assault operations. They want you to participate in developing those procedures." Marcus was both flattered and concerned by this proposal. "Sir, I'm not an engineer or a tactical expert. I just applied some construction techniques my father taught me." Harrison smiled. "That's exactly why they want your input. The Army has plenty of engineers and tactical experts. What we don't have enough of is people who can look at standard equipment and see unconventional uses for it." Over the following weeks, Marcus found himself assigned to a special project developing new techniques for using truck-mounted winches against German fortifications. The project was based at division headquarters, but it required frequent trips to forward positions to test procedures against actual German defensive structures. The work was fascinating and dangerous in equal measure. Marcus learned that German defensive engineering followed predictable patterns that could be exploited by applying the right kind of mechanical force to the right structural points. Observation towers, communications bunkers, artillery positions, and even some types of tank barriers could be neutralized using winch techniques that required no special equipment beyond what every truck unit already possessed. The most successful operation occurred in late November, when Marcus led a team of 6 trucks in a coordinated assault on a German communications complex near the town of Savin. Using synchronized winch operations, the team brought down 4 separate structures in less than 30 minutes, completely disrupting German communications for an entire division. But the operation that Marcus remembered most clearly was much smaller and more personal. In early December, his unit was supporting an infantry advance near the German border when they encountered a German defensive position that had trapped a squad of American soldiers in an abandoned farmhouse. The German position was a reinforced bunker that commanded excellent fields of fire and was too well constructed to be destroyed by the available artillery. Conventional assault tactics would have required sacrificing several American lives to eliminate the position. Marcus studied the bunker through binoculars and recognized the same construction techniques he had seen in dozens of German defensive positions. The structure was strong, but it had predictable weak points that could be exploited using winch operations. Working with Chen and Rodriguez, Marcus positioned his truck to attack the bunker's ventilation system, a steel and concrete structure that provided air circulation for the German position. By applying tension to the ventilation assembly, they were able to create a structural failure that filled the bunker with concrete dust and forced the German defenders to evacuate. The trapped American soldiers were rescued without casualties, and the German position was neutralized without requiring a costly frontal assault. But what made the operation memorable for Marcus was not the tactical success. It was the moment when he realized that his improvised engineering techniques had evolved into a systematic capability that could save American lives on a regular basis. After the conflict ended, Marcus returned to Detroit and resumed his studies in mechanical engineering at Wayne State University. He used his veterans' benefits to complete a degree in structural engineering, specializing in the analysis of building failures and demolition techniques. In 1948, he joined his father's construction company and eventually became a nationally recognized expert in controlled demolition. His work contributed to the safe removal of dozens of obsolete industrial structures throughout the Midwest, including several massive factory buildings that had been considered too dangerous to demolish using conventional techniques. But Marcus never forgot the lesson he had learned on that cold October morning in France, that the most powerful solutions to seemingly impossible problems often come from looking at familiar tools in unfamiliar ways, and that sometimes the greatest courage is required not for charging into battle, but for standing still under fire long enough to attach a winch cable to exactly the right structural point. In 1955, Marcus established a scholarship fund at Wayne State University for students studying mechanical engineering with an emphasis on creative problem-solving. The scholarship was funded by royalties from a series of patents Marcus had obtained for improved demolition techniques based on his wartime innovations. The scholarship fund's mission statement read, "To support students who demonstrate the ability to see unconventional solutions to conventional problems, and who understand that engineering is not just about building structures, but about understanding how and why structures fail." Every year, scholarship recipients receive not only financial support, but also a letter from Marcus describing the events of October 15, 1944, and explaining how a young truck driver's knowledge of construction techniques had ended up changing the course of military operations in eastern France. The letter always concluded with the same paragraph. "Remember that innovation is not about having access to the most advanced technology or the most sophisticated equipment. Innovation is about understanding the fundamental principles that govern how things work, and then applying those principles in ways that nobody has thought of before. Sometimes the most powerful weapon in any conflict is a standard piece of equipment being used by someone who understands exactly how and why it works." Marcus maintained correspondence with several of his fellow drivers throughout the post-conflict years. Chen became a successful businessman in San Francisco, eventually owning a chain of automotive repair shops that specialized in truck maintenance and modification. Rodriguez returned to El Paso and became the chief mechanic for a major trucking company, where he trained hundreds of drivers and mechanics in advanced vehicle maintenance techniques. Morrison remained in the military after the conflict and eventually achieved the rank of full colonel. He spent much of his later career developing new logistics procedures that incorporated the lessons learned from Marcus's improvised engineering operations. Morrison's final assignment before retirement was as director of the Army's Logistics Innovation Center, where he oversaw the development of standardized procedures for using standard equipment in non-standard ways. In 1962, Marcus received an invitation to attend a reunion of the 272nd Infantry Regiment, the unit that had been trapped by the German observation tower on October 15, 1944. The reunion was held in Detroit, and Marcus was surprised to discover that he was considered the guest of honor. The infantry veterans had organized the reunion specifically to thank Marcus for his actions that day. Many of them had never known the details of how they had been rescued from their impossible tactical situation, and they were amazed to learn that their salvation had come from a truck driver with a standard military winch. Staff Sergeant Robert Murphy, who had been a private in the trapped infantry unit, approached Marcus during the reunion dinner. "I want you to know something," Murphy said. "After you brought down that tower and we were able to advance, we found German documents that showed they were planning a major counterattack for that afternoon. If we had still been pinned down in our positions when that attack came, most of us wouldn't have made it home." Murphy's revelation provided Marcus with new perspective on the significance of his actions. He had always known that his winch operation had been tactically successful, but he had never fully understood the broader implications. The German observation tower had not only been preventing American advancement, it had been coordinating preparations for an attack that would have resulted in heavy American casualties. At the reunion, Marcus met dozens of veterans whose lives had been affected by the events of that October morning. Some had been directly involved in the breakthrough that followed the tower's destruction. Others had participated in subsequent operations that were made possible by the American advance through the valley. But the conversation that affected Marcus most deeply was with Private First Class James Wilson, who had been wounded during the fighting that preceded the tower's destruction. Wilson had spent 6 months in military hospitals recovering from his injuries, and he had been told by his doctors that his survival depended on the speed with which he had been evacuated to medical facilities. "The thing is," Wilson told Marcus, "I couldn't be evacuated until that tower came down. The Germans had all the routes out of the valley under observation. If you hadn't figured out how to take out that position, I would have bled to death waiting for a medical evacuation that could never come. Wilson's words helped Marcus understand that his improvised engineering solution had saved lives in ways he had never considered. The tactical breakthrough had been important, but the humanitarian implications, the ability to evacuate wounded soldiers and resupply trapped units, had been equally significant. After the reunion, Marcus began writing a detailed memoir of his wartime experiences, focusing particularly on the technical aspects of using standard equipment for unconventional purposes. The memoir was published in 1965 under the title The Winch and the Tower: Engineering Solutions to Military Problems. The book became required reading at several military academies and engineering schools. It was praised not only for its historical value, but also for its insights into creative problem-solving under extreme pressure. The chapter describing the German tower operation was frequently excerpted in textbooks on mechanical engineering and structural analysis. But Marcus was most proud of the book's influence on a new generation of military engineers and logistics specialists. He received hundreds of letters from readers who had applied his techniques to their own professional challenges, both military and civilian. One letter from a civil engineer in California described how Marcus's approach to analyzing structural weak points had enabled the safe demolition of an earthquake-damaged bridge that conventional techniques could not handle safely. Another letter, from a military engineer in Vietnam, explained how winch techniques based on Marcus's innovations had been used to clear obstacles and remove fortifications with minimal casualties. In 1972, Marcus was invited to speak at the United States Military Academy at West Point. His lecture, titled Logistics Innovation in Combat Operations, was attended by more than 400 cadets and faculty members. During the question and answer session following his lecture, a cadet asked Marcus what he considered the most important lesson from his wartime experiences. Marcus thought carefully before answering. The most important lesson is that innovation doesn't require perfect knowledge or ideal conditions. On that morning in France, I didn't know whether my plan would work. I didn't have detailed engineering calculations or computer models or expert consultations. I had a basic understanding of structural mechanics, access to standard equipment, and the willingness to try something that had never been attempted before. He continued, but I also learned that innovation without preparation is just luck. The reason I was able to improvise a solution to that tactical problem was that my father had taught me to understand how structures work and how they fail. The creative insight came from applying that fundamental knowledge to an unprecedented situation. The cadet followed up with another question. Sir, how do you prepare for situations that you can't anticipate? Marcus smiled. You learn the fundamental principles that govern how things work, and you practice applying those principles to different kinds of problems. You develop confidence in your ability to analyze new situations and improvise solutions using whatever resources are available. And most importantly, you remember that the most sophisticated technology in the world is useless if you don't understand the basic physics that makes it work. After his retirement from the construction industry in 1975, Marcus devoted most of his time to educational activities. He established a workshop program for high school students interested in engineering and mechanics, where students learned to analyze and solve practical problems using basic tools and equipment. The workshop program was based on the same principles that had guided Marcus's wartime innovations: understanding fundamental mechanical concepts, learning to see conventional equipment in unconventional ways, and developing the confidence to attempt solutions that had never been tried before. Hundreds of students participated in the workshop program over the years, and many went on to successful careers in engineering, construction, and related fields. But Marcus was most proud of the students who learned to approach problems with the same combination of technical knowledge and creative thinking that had enabled him to bring down a German observation tower with a standard military winch. Marcus Washington died peacefully in 1993 at the age of 67. His funeral was attended by family members, professional colleagues, and dozens of former students from his workshop program. But the most unexpected attendees were veterans from the 272nd Infantry Regiment, men in their 70s who had traveled from across the country to pay their respects to the truck driver who had saved their lives nearly 50 years earlier. The gravestone in Detroit's Woodlawn Cemetery bears a simple inscription. Marcus Washington, 1926 to 1993, engineer, teacher, problem solver. Below the inscription is an engraving of a military winch with a steel cable extending toward a toppling tower. But perhaps the most fitting memorial to Marcus's legacy is found in the curriculum of the United States Army's Logistics Officer Advanced Course, where his techniques are still taught to military engineers and logistics specialists. The course includes a practical exercise in which students must use standard truck-mounted winches to overcome various types of obstacles and fortifications. The exercise is known as Washington's Challenge, and it requires students to demonstrate not only technical competence with winch operations, but also the creative thinking necessary to see unconventional solutions to conventional problems. The exercise concludes with a case study of the German observation tower operation, emphasizing the importance of individual initiative and innovative thinking in military operations. The case study always ends with the same conclusion. Private First Class, Marcus Washington's actions on October 15, 1944, demonstrate that the most powerful capabilities in any military organization are not necessarily the most sophisticated weapons or the most advanced technology. Sometimes the most powerful capability is a standard piece of equipment being operated by someone who understands exactly how and why it works, and who has the courage to use it in ways that nobody has ever attempted before. Today, Marcus Washington's story is remembered not only as an example of individual courage and innovation, but also as a demonstration of how fundamental engineering knowledge, combined with creative thinking and determination, can overcome seemingly impossible obstacles. His story continues to inspire engineers, military officers, and problem solvers of all kinds, proving that sometimes the most effective solutions to complex problems are found not in advanced technology or sophisticated equipment, but in the creative application of basic principles by individuals who understand that innovation begins with seeing familiar things in unfamiliar ways. The principles that guided Marcus's wartime innovation, understanding fundamental mechanics, recognizing structural weak points, and applying the right kind of force to the right place at the right time, remain as relevant today as they were on that cold October morning in France, when an 18-year-old truck driver changed the course of a military operation with a standard winch and an unconventional idea. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.